Alrighty guys, so this video here that you're about to see is a little bit something out of my wheelhouse, but thought it was quite interesting, and who knows, may save somebody a limb or some life. The REA power demonstration, which I never realized that tree branches could be conductive or anything, or even fiberglass with that much voltage. So enjoy this clip here, and I think you'll see how much I jumped when that first fuse popped, and yeah, just hopefully, hey, maybe it helps somebody out and bring some awareness somewhere. So anyhow, later guys. Cracker videos to come.
He's a chief, journeyman lineman, and Chad's here on the side. He's a journeyman lineman. We're doing this demonstration not to scare people, but to educate on safety of electricity. Approximately 1,000 people die and 30,000 people are hurt in electrical accidents. If the electrical path is broken to ground, electrical current will travel through you to ground. Good conductive material is gold, silver, aluminum, and the human body, which is made up of 3/4% of water. Good non-conductive material is like the rubber blanket Brian's standing on. The shotgun stick is fiberglass, which is tested for 100,000 volts. The line hose, which is up on the line, the neutral and the primary, and plastic insulators and glass insulators we use to insulate the line. I'm going to start pointing out the hardware. We got transformer 1, the secondary bushings, the primary bushing, which puts out 7,200 volts into the transformer, the lightning arrestor, the cutout, and the cutout door. That's normally what blows when we have a fault. We have a street light. The primary line is up top, the neutral line, and then the phone line. And then we have an OCR in the middle, and then transformer 2, and the second street light. We're going to create some faults, so we're going to go phase to ground. So that center cutout's probably going to blow, and it's going to make some noise. Our first demonstration is going to be the Squirrel. We have a lot of animal outages, birds, bats, raccoons, squirrels. So Buddy the Squirrel, he likes to climb up the pole and get himself out there, play around, and then he seems to have a bad day, and the fuse blows. So now we gotta get a call from dispatch, and then we'll go out and we'll patrol the line from where that fuse is, out through the line, and then we come across the Squirrel, and then we get him off the top of the transformer and clear him from the fault. And then what Chad's doing is he's refusing the door. And we'll get our long fiberglass pogo sticks out, and we'll put a cutout up there, and he'll get your lights back on. Watch transformers 2 light up. So now we have the Raccoon. He likes to come out at night. He gets up there and climbs around, and he fools around, and he has himself a bad night. And now we got to come out 2 or 3 o'clock in the morning from dispatch call, and with our flashy lights and big go lights, we'll shine down the line and we'll try to find the fault. And we'll find this Raccoon normally laying on the ground, and we'll clear it and we'll refuse it and get the lights back on. Our center OCR there is our next demonstration. OCRs are protective devices programmed to trip more than once, so blinks do occur, but if any minor fault that are cleared, quickly allow the lights to stay on, minimizing outages. When I energize this, both lights are going to be on. Transformers 2 light's going to go out. You may be able to hear it. OCR is going to click when we create a fault with that Raccoon. And if it would only click twice, the lights would stay on. But we're going to click it all 3 times. And as you could hear, it clicked, and then if it, like I said, if it only clicked once, that light would have stayed on and the fault would have been cleared. But we kept it on there to click it to get it to open. These are this is a dead end bell, which was tracking during the rain, which is sometimes hard to find. This is an insulator that happened to track and burn up. This was a really hard one. We have to try to find that pole with the binoculars, that little hole in that insulator from 40 feet from the ground, and it's 40 to 45 feet up in the air. This was a lightning arrestor that took on some lightning, and sometimes those are hard to find. Our next demonstration is kite strings and marlin balloons. Drones, kites, or marlin balloons, never try to retrieve them yourself if they get away from you. Call your local electric utility for assistance. I'm going to energize this trailer. You can see through Transformer 1's lights on. There's nothing hanging in our cutout door, and Transformer 2's street light is out. Chad's going to hang the string on the cutout and put electricity through that kite string and light Transformers 2's light up.
Wow.
And next he's going to do it with one aluminum marlin balloon. Mr. Smiley.
$7,200 volts.
If you can see Transformer 2's lights out, you can hear the electricity flowing through there. Next, I'll show you how conductive a tree limb is. We'll do the same test.
Wow.
We'll put it up through that cutout and we'll light that Transformer 2 street light up. Tree limbs cause a lot of power outages during storms. As you can see, that tree limb is lighting up that street light.
Wow.
Electricity flows through that. Don't cut trees or tree limbs that can come within 10 feet of a power line. Only specialized tree trimmers who are qualified should do so. If you come in contact, you'll create a path to ground. A path to ground through that tree limb is you standing on earth, on the ground, on this pavement, through that tree limb to that power line. And electricity will follow through you to the ground. Now we'll do a demonstration where he creates a fault with that, and we'll try to burn some of those limbs off. Storms create a lot of power lines. Is there any first responders here? We always ask first responders wait till we show up to cut the trees off so that we can isolate and make the line safe. You can see the limb burning because it's going to path to ground through that neutral wire. Eventually it'll dry out and it'll burn limbs off, little leaves off. See, it burnt the limb. So,
Wow.
Always assume a power line is energized and deadly. Electricity is referred to as silent killer. It can't be heard or smelled. Always stay 50 feet away. We're going to do insulate and isolate. That's where a lineman protects himself with putting rubber line, hoses up, blankets. We wear tested rubber gloves and sleeves that are about 20,000 volts. PPE is a hard hat, Z87, safety glasses. We wear FR 8-calorie clothing and EH rated boots. Brian's going to take that and we're going to go ahead and put it on the line hose and show you how we're protected. Now with that having a hole in it, he's going to arc it off the line and show you how dangerous this little pinhole could cause.
I really don't know if the camera catching that.
That arc being created is 35,000 degrees. It's hotter than the surface of the sun. Test, tag, and ground. That's what we normally do. We'll test the line to make sure it's de-energized. We'll remove a lead from the energized source, and we'll also put a ground on. That's what protects the lineman from getting hurt. This tester is only to test it to let us know that we are able to do that. We're able to put the ground on. It does not protect you. Brian's going to test it, and it's beeping. It's letting us know that that line is de-energized, and as quick as this, the line, it's a solid beep. That line's now energized. Just the tester alone will not protect you. We're going to show you how to backfeed a generator. This is not the correct way to do this, and do not do this. This is the incorrect way. Chad is setting it up, and he's going to start that generator. Now, this is going to go through transformer 2 up through the secondary bushings, and it's going to go out the primary. Once it puts voltage back into the primary, it's putting 7,200 volts back into that. So if there's a responder or a lineman out there working or trying to clear up something, that's how quick that generator fired up and put 7,200 volts back into that line. Always have a transfer switch installed by a qualified electrician on backup generators. We have EH rated boots. We wear normal tennis shoes or rubber, and they are non-conductive, but they normally got pinholes in them, grease, grime, bubble gum. You know, we're going to show you how conductive a little rubber boot is. If it's got holes, grease, grime, or whatever on it. Step potential is like the ripples in a pond when you throw a stone. If you step one step, the electricity will flow up through one leg and then out through the other. Watch the ground pad.
Wow.
That's 35,000 degrees there. When you got an aluminum ladder and you're throwing it around the house or anywhere near power lines, always look up. When using a long pole, extended tool, or ladder, carry long items horizontal instead of vertical. This is our little boy climbing his pipe and gets up into the lines. Underground utilities. The contents of a pad-mount transformer box are the same as those found on the utility pole and are connected to underground power lines. Respect underground utilities lines by calling 811 or your state's underground location service at least 3 days prior to starting a digging project. This allows utility locators to mark any underground utilities. This service is free. Carpool accidents. If you're in a car, tractor, cab, or any type of machinery equipment that comes in contact with a power line, pole, guy wire, or pad mount transformer, staying in the car or cab is usually the safest place to be. Stay where you can call 911 and wait for the electric utility to arrive and de-energize the power. If you must exit a vehicle or cab due to smoke or fire, there is a recommended method that you can help avoid electrocution by jumping out and maintaining a solid stance and avoid touching the car or cab while exiting. Don't touch nothing metal inside the car if possible. Then keeping your feet together, you make solid jumps and jump bunny hop 50 feet away from the vehicle. Notify people to stay back. If you see someone in trouble, don't run up right away, because running up can expose you to an electrical shock, because you're 75% conductive. Our last demonstration we're going to do here today is a hot dog. A hot dog simulates your bodies. It's like gristle, fat, and water. This will show you how bad electricity will cook you.
You stepped on the curb and were shivering.
Pay attention.
Electricity doesn't care if kids lose their fathers or wives lose their husbands or families are hurt. Be smart, be safe, stay safe. This concludes our demonstration. We'll be back around 6 o'clock to do another one.